screen. So let me turn on the projector. All right, so the first thing we're going to do is talk about the concept of exceptions. So how many of you could imagine in a program or application in which, I don't know, let's take a look at this one right here. When a program tries to divide by 0, what will happen if you actually type this out into a Java compiler or IDE? You are going to, and for the purposes of time, I'm just going to say you're likely to get an exception, and the exception is that the program is trying to divide by 0. Now, the bad thing is that this is going to be part of, like, let's say, for example, the back end of somebody that's, posting the answers to questions. So expand your mind. Instead of saying int result equals 10 divided by 0, let's say it was something to calculate payroll or something like, for example, how many hours did you work by, how many hours what was your hourly rate, that kind of a thing. Okay, so think of like 10 and 0 to be somebody answering questions to that would result in somebody typing the integer 10 and somebody typing 0. Okay, and the idea is that if you take a look at this as part of an overall program in which you're asking potentially somebody to post figures in, and this is the result, what will happen? The program will shut down. It'll just quit. Okay, and that unfortunately is a bit of a hack in of itself. So the idea is, keep in mind, like any public-facing kiosk or anything that asks you to enter in figures. It could be your Amazon user interface, for example, when you want to buy an item. Okay, if you tried to, that's why there's this least amount. You ever notice with an Amazon item or something, you can't go below 0. You just have the upper and the lower, so you can order more. You can order one, or do you ever try to order the same thing a couple times? Maybe your web browser stalls, so you go back in and order it again just to make sure you wind up with 2. That happens, so you just got to reduce it by 1 just to make sure you're just getting 1, because you don't need, 2 of the latest book by, or you don't need 2 Taylor Swift CDs. You just need 1, but so you reduce it by 1. But you notice you can't go below 0, okay, because there's a stopgap there, right? So you can. It used to be you had a lot of open ended fields. So like if it's a quantity, you could put 1 or 2 or 0, but maybe you could put 3 or something. -3, shall I say? If you put -3, you could potentially cause whatever program that was running that online store to shut down because of exceptions. And that sometimes that is part of a plot, if you will. And as a matter of fact, that is the ultimate consequence of, for example, of that. What is it? When you just try to spam a denial of service, a denial of service attack, DDoS, distributed denial of service. So that's the idea here, is we want to prevent that from happening. So to do that, and we have a number of exceptions here, we can do the simple try-catch approach. So here we can try int result equals 10 over 0, and we can say catch arithmetic exception E you cannot divide by 0. So we're catching that exception, and then we're going back to this so that the program won't just shut down due to an exception. Okay, there's other exceptions right here as well. For example, a very popular one is array out of bounds exception. Array out of bounds exception. So that's when we have int numbers equals 1, 2, 3. Notice what is the problem here. Can somebody tell me what the problem is here? Now, I already know you know, Mr. Linux.
You're giving me too much credit.
Yes.
There's no 5.
Yes. Yeah. Well, it's not that there's no 5. Give me an example of.
There are only 3 in there.
Right. 3 spaces. Right. And actually, you can really. What if we put the number 3 here? Would that be okay?
No.
Yes. Very good. Very good. Very good. Okay. Okay. So there's array out of bounds exception, number format exception, in which it's looking for a string text that at least has some sort of an integer, something that can be converted to an integer using the .parseInt method. And we talked about this being a factory method, right? Remember we talked about it being a factory method because we can just run this without the new command. Okay, so, but anyways, and if we tried running this, it would result in an exception, the number format exception, because it's trying to convert bad text into a number. Okay, I'm just going to do something real quick here. Let me bring up my other PowerPoint. Okay. Okay, so again, with the exceptions, here's an exception. Here's an exception in general right here. We have example 4. So let's take a look at some of the syntax right here. So I talked to you about arrays. So what were some of the limiting factors of arrays? Well, some of the limiting factors of arrays is the fact that you can only use one type of data, and you can only use your data had to be fixed. So you could not change something in runtime, right? So we have a list, and we have Gemini, Leo, Cancer, Gemini. So what can we say about this list? Do we have any repetitions of terms here?
Yeah, we do.
Really? Are you sure?
Well, it depends.
Now, a list keeps track of how many things? A list keeps track of what? The specific item, okay? But how is it able to decipher between both Geminis? This is Gemini here and Gemini here. I am a Gemini. That's why I put Gemini twice when I make this up.
So they both have different places in memory.
Very good. They have different places in memory because a list not only it keeps track of the items in the list, it also keeps track of how they are resolved. They are resolved in terms of offset. Okay? So a list keeps track of the item, and it keeps track of the offset as well. So we have so it looks at this as being Gemini, and it also looks at this Gemini being offset 0.
So it's called an offset, not an index, or can they be?
That's what I mean by offset is index. So index or offset, okay. And then we have Leo, that's off the list. Leo's Leo, offset or index 1. Cancer is offset or index 2. And I call it an offset 2. I mean, you can, technically you're right, it is an index, but I refer to an offset because many people don't realize that this isn't 1, this is 0.
Yeah.
It's the 0 offset. Even though from like if you worked at a library, this could be indexed as 1 because it's the first position, but and the offset is 0. That's why I want you to.
Yeah, indexes generally don't start at 0. I get it.
Yeah, I know. The only one of the only programming languages that I know that actually starts at 1 is MATLAB. And if you ever want to guess, hey, you went like this. You have a question?
Yeah, I was
Really?
ready to finish.
What? Oh, okay. Yeah. I'm sorry. I'm sorry to be anticlimactic. I'm done. Sorry.
But, I
Yes.
didn't have a question, I was waiting for you to finish. So, I was a little confused. Does that list function like a stack, first in, last out?
It does. It does. Yeah, we this in a first year or first a Java class. You're not expected to be worried about that. I mean, most Java classes, first year Java classes, focus on arrays. So this is kind of advanced for Java, whereas Python, you learn lists on day 1 because lists in Java in Python are different than lists in. But anyways, that being said, the point of this is that a list keeps track of the item as well as the offset or index. Now let's take a look at what happens here. It's going to then print the zodiac signs. Now the other thing about lists right here is that you can actually print it out. You can just print it out just by printing zodiac signs, and it'll print the list, unlike an array, which you have to run every trick in the book. You have to do the toString and all that. So with lists, it just prints out like this. Now let's talk about sets. Here we have a set, and I just decided to call it zodiac signs 2. And this is how you create a new set. This is how you use the new hash set, the new term for set. Okay, and so then we say zodiac signs 2, add all zodiac signs. So in other words, we're taking this list and we're adding the list to a set. So we're basically turning this list into a set. Well, wait a second. What is a set? Somebody tell me what a set is. Well, both a list and a set are, and an array, for that matter, are collections of items. Okay? Now, an array is the most, I guess you could say, simple of all Java collections, in which it has the least amount of services attached to it. It's like your parents' maybe you acquired your first car. Like for example, let's say you take a typical 1980s. That's why I want to say, because everyone's poor in 2026. But let's say it's in the 1980s, and you're taking a typical business person's track, in which he goes to a 4-year, a prestigious 4-year college. He decides to get a great, he happens to get a great job, okay, and he gets a nice new car from the company, or he buys it, he can afford to buy it on his own, and then he progresses and he buys a dream car when he's 60 years old, okay? Now, an array would be compared to maybe his first hand-me-down car that his parents maybe gave him in high school or college, right? It just did the trick. That's all it was meant to do, was to take him from point A to point B. That's all it was meant to do. But as he was able to progress through his career and starting a family, and he had some, as he was able to progress, he was able to buy himself another car. Sorry. He was able to buy himself another better cars. So what I'm trying to say is an array would have been like his very first car. An array just does the trick. That's all it is meant to do is to collect items in one single data structure. And there's no other niceties. So that's like the dude's first car without any AC. Maybe the brakes squeaked. Maybe he's got some dents in it, some rust, some Bondo color. Maybe he's got a piece of duct tape on the back window. Maybe it's missing, one of the side mirrors. And it's like, it just barely is able to go forward, but maybe it smokes a little bit, but it just gets him from point A to point B. There's no niceties. Now, his end car has got all this stuff, and it's got all these services attached to it. That's what, like, as you progress from an array to, say, a list. A list, you can do so much more with it, and we're not going to worry about what you can do, just so you know that there's other data structures that are out there. And in a first year programming class, we just ran out of time for covering each thing. But just know that there are different collections out there. Okay, so we have lists. But then we wind up here in a set. So how does a set differ from a list? Somebody tell me. Well, okay, we'll go over that in just a second. Let me just move on down with this. So here, here is the try-catch. Okay, so we have int my numbers equals 1, 2, 3. System out print line my numbers, and it's going to say print line something went wrong. So let's go ahead and let's see. The name of this program is simply example 4. Okay, so let me do cat example4.java. So this is the program right here. So we create a list of the different zodiac signs: Gemini, Leo, Cancer, Gemini, and then we have and this adds this list that was created. It adds it to Zodiac Signs 2, which is actually a set, and so it prints the set, Zodiac Signs 2. So let's see what it does. So as you can see, it does print out lists of zodiac signs: Gemini, Leo, Cancer, Gemini, but then it says set of zodiac signs: Leo, Gemini, and Cancer. So what do we observe that sets do in Java? It takes a collection and it only prints out the unique items. So in other words, a list is able to track and frankly iterate each individual item, as well as keep track of the associated offset or index number. That's a list. So a list can do two things. A set, all it does is it keeps track of just the unique items. There's no sense of order with a set. No sense of order. All right? So it does not recognize the fact that the Gemini is at the first, at the 0 point and at the last point. It only recognizes the existence of Gemini. Yes?
So would a set be good if you're, for example, making a survey program and you want to know how many people answered this specific question or something like that?
Yes. If you are going to see, if you're going to index it by household, it all depends. Surveys are great for political reasons. So if there's if there's 4 members of a house, you can say all 4 members of the house agreed to say yes on Prop A, as an example. But remember, you might have 2 parents and 2 kids. Well, the 2 kids might not be eligible for voting. Okay, so this is then when you can say, all right, we can say that 2 of the 4, like all 4 said yes, but only 2 were voters, so 2 of the 4 only count. So actually, we're in that house, we're down to 2. And then all of a sudden, if you just wanted to, if you had all these names and then you had their associated addresses, if you wanted to minimize the impact, you could do set analysis on the individual addresses and do it that way. If that makes sense.
Interesting. Yeah, that's more complex than I was thinking. I was thinking like
Sorry.
a sample size of like 3,000. How many?
I know. I had. Yeah. But very good. Very good. Okay. Here is the next. So that is. So we're not gonna do that PowerPoint yet. Where was the other one? Okay. Here we go. So this I'd like to introduce.
MIDI files.
Huh?
I love MIDI files.
Yeah, so we're going to experiment with that today. Now, MIDI files, of course, need a sequencer object which plays the music, and it's in the library JavaX sound.midi package. Okay, we're going to look at that today, and we're going to do, and this is where the try the sequence comes in. So we're going to import the library, and this is music test 1, and this is the method play, and this is where we're going to try. What are we trying to do? We're trying to get the sequencer. The problem with this, I just want to tell you that you can't just have a try without the other. You actually you cannot have a try without a catch. Okay? You can't have a try without a catch. Now, it is getting to be the end of the semester, so really we're only going to have one assignment dealing with try and catch. Okay? So just because there was so much we had to go through with all the mortgage stuff and everything, so. And it is about managing risk. So the problem is you might have a method calling inside of a class you didn't write because you're doing libraries. That's why try and catch when you're dealing with libraries is so important, because if, for example, there's no sequencer, okay, so if you're trying to run a MIDI file and there's no sequencer right here, okay, then you killed the program. So that's why try and catch is very, very important. Okay, and the get sequencer method does take a risk, okay, and if you take a look at the Java API just online, you can see that it throws this unavailable exception right here, which again kills your program. So you can add a catch statement to match the exception, okay, in which we do successfully got a sequencer. So let's run this one. Let's see. It's music test 1. Well, let's see if it's even in here. Let's see. Okay, that one is not in here. My apologies. Okay, it's okay. Okay, so here we have something that that happens. Oh, and the other keyword is finally. Okay, finally happens when even if it doesn't catch it, or if something happens here, finally is a keyword that will happen no matter what. It'll run as the very last thing. In this case, we wrote, "That's a rat." Okay? And as an example, you cannot catch a finally without a try, no code between try and catch. A try must be followed up immediately by a catch or finally. A try with only a finally, no catch must still declare an exception. And here is the final meaty example right here. Meaty example. And actually, I have in our here, this is where one of the aspects of fun will occur, is in our ICE today. All you have to do is download Beatbox Java right now, compile it, and it runs the full Beatbox right here. Let me run it for everyone. Okay, when you download and run the Beatbox program to run it, first you have to compile it, and then when you compile it, when you run it, you just have to type in Java space beatbox.java. So you run it with the extension. Okay, and here it is right here. So you can start it. And then you can start different like beats right here. There's some cowbell. Okay, so you can run different things. So download it, try it out, run it, and work on your exercise for like the next 15 minutes. It's due at midnight tonight, but it's simple. It's really simple. It literally asks you to, well, I'm not going to spoil the surprise. Just go ahead, take a look at it. And then we're going to go over, like I'm going to give you 15 minutes, and then guess what we're going to do? We're going to go over user interfaces. So we're going to have a little bit of fun today.